Measures of dispersion. What is meant by the word dispersion? It is the degree to which numerical data tend to spread about an average value is called the dispersion of the data. What do you mean by this statement? For example, there are two classes. In one class, we have 20 students, in which 10 students got 0 marks and remaining 10 students scored 100 marks. Similarly, we have another class 2. Here also we have 20 students, but here all the 20 students scored 50 marks. In the class 1, what will be the mean over here if you calculate? Mean is 100 into 10 by total is 20. We'll get 50 as the mean. Similarly, if you calculate mean over here, that is 50 into 20 upon 20, that is 50. So if you observe, the mean is same in both the classes. So if you give the mean to any person, he can't tell the inner data, like what's happening actually in the data. If you observe, the mean is same, that is 50. But in the class 1, 10 people got 0 marks and remaining 10 got 100. Whereas in class 2, all got 50 marks. Here, the data is not dispersed. Now you are getting the point, right? Now you understood the word disperse. So here the data is not dispersed, it is centralized at one point, that is at 50 marks. Whereas here the data is dispersed from 0 to 100. So this is called the dispersed data and this is called the not dispersed data. So this dispersion includes two concepts, in which one is the mean deviation and second standard deviation and variance. And variance. Mean deviation is nothing but we need to calculate the dispersion at a particular point, that is usually will be the mean. But in the question itself, if it is asked to find the dispersion at some point like median or at any other value like 30, 25 according to the data, then we'll use the mean deviation method. If they particularly say standard deviation or variance, here we will calculate the dispersion at only the mean. Okay. Mean deviation can be at mean or else at any other point according to the question. But standard deviation and variance are calculated at the point that is mean. Now let's see how it is and let's see how we calculate the mean deviation and standard deviation and variance. The first type of measure of dispersion is mean deviation. It is also called as mean dispersion. Both the word dispersion and deviation are similar to each other. What is its definition? It is the mean of absolute value of deviations about a fixed point. What do you understand by this? So let's take an example. If there is a data like 5, 10, 15, 20, 25, 30, 35. Assume these are the number of runs scored by a cricket person. Assume these are the number of runs scored by a cricket player. Now, if you calculate the mean of all this data, what will be the mean? That is 20. Okay, you guys calculate and see, it will be 20 itself. Now, you will stand on this point and check how much this point is got dispersed. What the value you will get? You'll get 0 because you are standing on the same point and calculating its dispersion. So obviously, the dispersion of this point will be 0. And if you stand here and check the how much 25 got dispersed, you'll get plus 5 because the difference is right. Similarly, in the backwards, if you calculate how much 15 got dispersed from 20, you'll get minus 5. Similarly, if you calculate for 30, you will get plus 10. And if you calculate for 10, you'll get minus 10. And if you calculate for 35, you'll get plus 15. And if you calculate for 5, you'll get minus 15. It's basically you are calculating the length or how much the point got dispersed from the average value, that is mean. So if you calculate, if you sum all these values, how much you'll get? You'll get 0. You'll get 0. But it's not the correct answer, right? Something it is dispersing. You are not getting 0 as the answer, except for 20 point because it's not dispersing. So we need to take the absolute values. That's what we have discussed. We need to take the absolute values of the deviations about fixed point. Here, fixed point is nothing but 20. So, how you are calculating? That is x, xi. I is nothing but any point. That is 5, 10, 15, 25, 30, 35. Minus m. M is nothing but the mean over here or a fixed point. This is the length. This is the deviation value, absolute value of deviation about a fixed point. Fixed point is nothing but n. Now we are taking the mean of these values, that is sum upon of sum of the deviations upon n. N is nothing but the total number of observations. So this is called as the mean deviation. We will calculate mean deviation by using this formula. It's nothing but the mean of absolute value of deviations about a fixed point. Again, in mean deviation, there are two types. That is for ungrouped data and for grouped data. Now, whatever we have discussed till now, it's all about the ungrouped data. Now, this formula is used for ungrouped data. Now, here M can be anything. If M is a mean, if M is a mean, then mean deviation will be sigma xi minus x bar upon n. If M is a median, then the mean deviation will be sigma xi minus median upon n. Now, let's see few examples. In this question, it is given that the mean deviation of the numbers are given, that is, the data is given to us, and it is told from their mean. Now, fixed point will be mean is 255. So, mean deviation value is given as 255, and we need to find the value of D. So, first, to calculate the mean deviation, we need to calculate the value of mean. So mean is nothing but x bar or m will be 1 plus 1 plus d plus 1 plus 2d plus so on plus 1 plus 100d upon. Now, what are the total number of observations we have? If you observe in the first bracket, that is, there is no d. So it is 0d. Whereas in the second bracket, we have 1d. Third bracket, we have 2d. So at which bracket we'll have 100d? It is 101th bracket. So total number of observation will be 101. So just calculate the mean. It is 1 plus 1 plus 1. How many times? 101 times of 1. So it was 101. Plus take d common. The inner part will be 1 plus 2 plus 3 plus so on till 100 upon 101. So you will get it as 101 plus d. It's a sum of natural numbers till 100. So n into n plus 1 by 2. N is nothing but 100 over here. 100 into n plus 1, that is 101 by 2 upon 101. Now you'll get it as 101 upon 101 plus d 50 101 upon 101. Now when you calculate, you'll get it as 1 plus 50d. Now this is the required mean. We got the mean. Now we need to calculate the mean deviation. That is the deviation from this point, that is mean. So what is the formula of mean deviation? That is sigma of xi minus m upon total number of observation. So here it will be xi. Xi is nothing but the observation points. First observation point is 1. So it is 1 minus mean. Minus 1 minus 50d. We need to take the absolute value plus. Next, x2. Second observation, that is 1 plus d minus mean minus 1 minus 50d. But absolute value. Plus third observation is 1 plus 2d minus mean, and last so on 1 plus 100d minus mean. But we need to take the absolute values upon total number of observation, that is 101. Now, if you simplify this, 1 and 1 gets cancelled and mod of minus 50d will be 50d. Plus again 1 and 1 gets cancelled. D minus 50 is minus 49, but mod of minus 49 is plus 49d. Plus here 1 and 1 gets cancelled and 48d. So on. And in between we'll get 0 also. When it is 1 plus 50d at 51st observation. And plus at 52 observation, it will be again D. And so on. Last at 101th observation, It is 100 minus 50, that is 50D. After 0, it will be plus, and before 0, it is negative, but we have taken the absolute values upon 101. Now, if you calculate this, take D common, and it is double. Every single element is getting double over here. So 2 times of 1 plus 2 plus 3, so on till 50 upon 101. Now again, sum of natural numbers, but till 50 over here. That is n into n plus 1 by 2. N is nothing but 50, n plus 1, 51 upon 2. This gets cancelled. So this is the leftover part. But in the question, the mean deviation value it is given as 255. So from here, D will be 255 into 101 upon 50 into 51. When you simplify this, you will get the value of D as 10.1. So this is the required answer for this question. So the value of D will be option B, that is 10.1. In this question, the mean deviation about the median is given, that is 50. And the data is also given, that is a comma 2a till 50a. And we need to find the value of mod a. But here, the main important thing to observe is it is given as median, not mean. Okay, first we need to calculate the median over here. So to calculate the median, first we need to see the number of observations. So number of observations in this question are, how many we have? 50 observations, right? So it is an even number. So at n by 2th position, that is 50 by 2, 25th position will have the value as 25a, and n by 2 plus 1, n by 2 plus 1th position, that is 25 plus 1, 26th position, we have the value as 26a. Now we need to take the average of these two values. So median will be 25 plus 26 into a upon 2, that is 25.5 a. Now this is the median of the given data. So to calculate the mean deviation, that is sigma xi minus m, that is nothing but the median in this question upon n. Now what is the xi? Xi are nothing but the data points. So first data point is a. A minus 25.5, that is 1 minus 25.5 is nothing but A minus 25.5a plus 2a minus 25.5a, so on till 50a minus 25.5a upon how many observations we have? We have 50 observations. So 1 minus 25.5 is minus 24.5, but we are taking the mod value, so it becomes plus 24.5 into a. It is 23.5 into a. So on, and in between we'll get it as 0.5a. That is minus 0.5, but if we take mod, we'll get plus 0.5. And also in positive terms, we'll get plus 0.5a, so on. Last 50 minus 25.5 is nothing but 24.5 a upon How many observations? 50 observations. So if you take A common and everything is repeating twice, so we are doing the twice of the value, that is 0.5 plus 1.5, so on till 23.5 plus 24.5. Now if you observe, this summation is following a AP, that is arithmetic progression. So if we use the formula, so the formula is n by 2 into A plus N, that is first term plus last term. So N is nothing but we have 25 observations. So 25 upon 2, A, that is 0.5 plus last term 24.5, that is nothing but 25. If you observe, the mean deviation value is given in the question, that is 50. So 2 and 2 gets cancelled. This 25 goes with 2 here, and this 25 goes with 2 times over here. So basically, the value of A will be 4 in this question. So the required answer is 4. So let's see the option. So the required answer is option B, that is the value of A is 4. Next, in mean deviation, there is second type, that is for grouped data. And in grouped data also, we have two types. One is discrete frequency distribution, and one more type is continuous frequency distribution. So, first one, that is discrete frequency distribution. Here, the data is given in such a way that there are n distinct values like x1, x2, so on till xn occurring with occurring with frequencies f1, f2, so on till fn respectively. So this data is represented in a tabular form like x points, that is x1, x2, x3, so on till xm, and frequency is represented as f1, f2, f3, so on till fn. So this is called as frequency distrib sorry, this is called as discrete frequency distribution. This tabular form is called as the discrete frequency distribution. And here also there are again two parts. First is about mean and second is about median. So mean deviation about mean will use the formula as mean deviation about mean is nothing but sigma fi xi minus x bar upon n, and mean deviation about median. Median, I'm representing it as capital N, is equal to sigma fi xi minus m. M is nothing but median upon total number of observation. So let's take an example. In this question, we need to find the mean deviation about mean, and the data is given to us. So first, what's the formula of mean deviation about mean? sigma fi mod xi minus mean upon n, that are total number of observations. So in the question, xi and fi are given to us. So let's write it those: 2, 5, 6, 8, 10, and 12. Fi are 2, 8, 10, 7, 8, and 5. From here, if we calculate sigma fi, just sum all these values, you will get it as 40. So this is nothing but the total number of observation, that is n. So here to calculate mean, that is x bar, it is sigma fi xi upon n. So first let's calculate fi xi for every data point. So we will get it as 2 into 2, 4, 8 5s are 40, 60, 56, 80, and 60. So here sigma, that is the total number, sigma fi xi, the sum of all these values will be 300. So the mean will be 300 upon 40. This is 7.5. Now we need to calculate the xi minus mean. So first let's do this for every data point. So xi is nothing but 2 over here. 2 minus mean is 7.5. We need to take the mod value, so it becomes 5.5. Next, 5 minus 7.5, 2.5, 1.5, 0.5, 2.5, and 4.5. Now, we need to calculate fi times xi minus x bar for every data point. So just multiply these frequencies with these values. So you will get it as 11, 20, 15, 3.5, 20, and 22.5. Now just add these all the values, that is sigma fi mod xi minus x bar will be 92. Just add and verify it. So mean deviation about mean will be this sigma fi mod xi minus x bar, just now we have calculated, that is 92 upon n. N is nothing but the total number of observations, that are 40. Now when you divide it, you will get the answer as 2.3. So this is the required answer to this question. Here we need to calculate the mean deviation about median for the given data. So the data is xi. So xi fi, as it is given about the median. So to calculate the median, we should also calculate the cumulative frequency. This we have already studied in class 9 and 10. I hope so. Now also we will again look into it, don't worry. Now after finding median, we need to calculate mod of xi minus m and also fi into xi minus m. So what's the formula about mean deviation about median? So it is sigma fi mod xi minus m upon n, that is number of observation. So xi is 3, 6, 9, 12, 13, 15, 21, and 22. Frequencies are 3, 4, 5, 2, 4, 5, 4, and 3. Now, how do we calculate the cumulative frequency? So first, cumulative frequency will remain as it is as the frequency for the first data point. Next, the cumulative frequency will become the frequency of its data point plus the frequency, the cumulative frequency of before data point. So when we add this both, we will get 7 as the cumulative frequency. Similarly, now we need to add frequency of this data point, that is 5, plus cumulative frequency of before data point. So 5 plus 7, it's 12. Next 12 plus 2, 14. 14 plus 4, 18. 18 plus 5, 23. 23 plus 4, 27. 27 plus 3, 30. Now, here the total number of observations will be 30, right? So, if we calculate the median over here, n is 30, which is an even number. So, median will be n by 2th position, that is 30 by 2, 15th position value, plus n by 2 plus 1th position, that is 16th position value upon 2. If you see this, so both this 15th and 16th observation lie in the value, lie in this cumulative frequency range of 18, right? This is the range where the 15th and 16th position values lie. So here the data point is 13. So 13 plus 13 by 2, that is 13 itself. So median we got it as 13. Now let's subtract it. 3 minus 13, that is minus 10, but we need to take the mod value. So 10. Next becomes 6 minus 13, 7. 9 minus 13, 4. 12 minus 13, 1. 13 minus 13 is 0. 15 minus 13, 2. 21 minus 13, 8. 22 minus 13 is 9. Now we got the values of sigma xi minus median. Now we need to calculate the frequency multiply. Now we need to calculate the frequency should multiply with this mod value. So just multiply it. 3 into 10, 30. 7 fours are 28. Next it becomes 20, 2, 0, 10, 32, and 9 threes are 27. So now we need to sum these all values. Just do the sum up. That is sigma fi mod xi minus m is nothing but 149. So the mean deviation about median will be 149 upon 30. When we do that, we'll get it as 4.97. This is the required answer to this question. The next type of mean deviation for the group data is continuous frequency distribution. It's a series in which data are classified into different class intervals without gaps along with their respective frequencies. It means, let's take an example like marks obtained and number of students. Marks obtained, the interval, class interval starts from 0 to 10. it's a one interval. Next, 10 to 20, the second interval, 20 to 30, 30 to 40. Okay, these are the four class intervals and they didn't have any gaps between them. It's ending with the 10 in the first class interval and second class interval starting from the same 10, right? And these class intervals have their respective frequency. Here frequency is nothing but the number of students, that is 12, 18, 27, 20. So this is an example of continuous frequency distribution. And in this also we have two types. One is mean deviation, about mean, and next one is mean deviation about median. Here, in the mean deviation about mean, while calculating the mean of continuous frequency distribution, we have made the assumption that the frequency in each class is centered at its midpoint. What does it mean? For example, if this is the class interval 0 to 10, then we will calculate its midpoint. What is its midpoint? 10 plus 0 by 2. The higher number plus lower number by 2. That is 5. So similarly here, 20 plus 10 by 2, 30 by 2, 15. 30 plus 20 by 2, 50 by 2, 25. And here, 35. These are the midpoints and we assume that the frequency is and we assume that the frequency is centered at these midpoints. Okay, this is how we calculate mean deviation about mean. And for the continuous distribution, we have already learned in our earlier classes that we'll find mean by using the assumed mean method. So that we'll discuss in the upcoming problems. So next is mean deviation about median. It is almost similar to that of mean deviation about mean. The only difference is that the replacement of mean by the median. That's it. And here for the continuous distribution, we will find median by using a formula which we have already discussed, which we have already learned in the earlier classes. But don't worry, while solving problems, we'll again recap it. So now let's get into the problems. In this question, we need to calculate the mean deviation about mean for the given data. The data is marks obtained and the number of students. Number of students is nothing but the frequency over here. Okay. How do we calculate mean deviation about mean? Sum of frequency is there. So xi minus mean upon n. N is nothing but the total number of observations. So first let's write the table. Xi will come Fi, that is the frequency. And next, how do you calculate the mean? Mean is nothing but sigma Fi xi upon n. N is nothing but sigma Fi. So next we need to calculate as Fi xi. After this, we need to calculate mod xi minus mean because from here we'll get the mean. Next, हेलो आंटी. आंटी मैं रूम पर ही हूँ आंटी. आंटी आप किधर है, एक्सटेंशन के पास या फिर ओल्ड के पास? ठीक है आंटी, 10 मिनट आ रही. Next, we need to calculate mod of xi minus x bar. From here, we'll get the mean, then we'll use the mean over here. After this, finally, frequency multiplied with xi minus x bar of mod. So let's keep the values. So xi is nothing but the midpoint of this frequency interval. I've already told you. So it is midpoint of 10 to 20 is 15. Next 25, 35, 45, 55, 65 and 75. And what are the respective frequencies? 2, 3, 8, 14, 8, 3 and 2. So what is the sum of all these frequencies? So that is sigma Fi is nothing but 40. This is also the total number of observations. So just multiply now Fi xi 30, 75, 280, 630, 440, 195 and 150. So now add these observations, that is sigma Fi xi will be just calculated. You will get it as 1800. So now we know sigma Fi xi and sigma Fi. So just substitute the values 1800 upon 40. How much you will get it as mean? You will get it as 45. So now subtract this 45 from each and every data point. So mod of 15 minus 45 is minus 30, but mod is there. So we need to only take the absolute values. So it becomes 30, 20, 10, 0, 10, 20 and 30. Now just multiply the frequency with these terms. So it becomes 60, 60, 80, 0, 80, 60 and 60. Now just sum these values, that is sigma Fi mod xi minus x bar will be 400. Now mean deviation about mean will be 400 upon 40 because total number of observations are 40. So the answer will be 10. So mean deviation about mean for the given data is 10. In this question, we need to find the mean deviation about median for the given data. And class intervals are given and the frequency is given. Frequency is nothing but Fi. So classes, from the class intervals, we need to find the midpoints, that is xi and Fi is given to us. And for the median, what's the extra thing we need to calculate? That is cumulative frequency. In the previous problem also we have discussed this, how to find it out. And now, next we need to calculate the median. It is a grouped data. So how do we need to calculate the median? We have a formula for this. That is L plus N by 2 minus C upon F into H. First, before applying this formula, first we need to find the median class. What is the median class? It is a class interval whose cumulative frequency is just greater or equal to n by 2, where n is the total number of observations. So median class is the class interval which satisfies this condition. So after finding the median class, L is called in the formula, after finding the median class, in the formula, L is called the lower limit of the median class and F is called the frequency of the median class and C is called the cumulative frequency of the class preceding to the median class. Preceding to median class. and h is called the width of the class. That is higher limit minus lower limit. So first, let's write this. So the midpoints will be 5, 15, 25, 35, 45, and 55. And the frequencies are given 6, 7, 15, 16, 4, and 2. So how to find the cumulative frequency? The first frequency will be the same, that is equal to 6. Next will be 6 plus 17, 13. Next 13 plus 15, 28. Next 28 plus 16, 44. 44 plus 4, 48. 48 plus 2, that is 50. So the total number of observation will be the last term of cumulative frequency, that is n will be 50. So what will be the n by 2? N by 2 is nothing but 25. So according to this, we need to calculate the median class. So we got the n by 2 now. Now we need to observe where is the median class lie. So I've already told you that median class is the class interval which has cumulative frequency greater than or equal to n by 2. So in this we need to check that where the cumulative frequency is just greater than 25. That is which interval? Midpoint is 25. So 20 to 30 interval, right? In this interval, the cumulative frequency is just greater than 25. And what will be the L? L will be 20 because it's the lower limit of median class. Next, what will be the F? F is the frequency of the median class, that is 15. Next, what is C? C is the cumulative frequency of preceding class. This is will be the C. This is F. And what is the height? Height is nothing but the width. That is 30 minus 20, 10. So let's calculate the median. So median will be L. What is L? We have 20 plus n by 2 is 25 minus C is 13 by F. What is that? 15 into 10, which will be 20 plus 8, that is 28. Now we got the median. The next thing to find in the tabular thing is mod of xi minus median and fi into xi minus m, because we need to find the mean deviation about median. So first let's do that. We got median as 28. So we need to subtract it from the data points. 5 minus 28. But we need to take only the absolute values. So it becomes 23, 13, 3, 7, 17, and 27. Now just multiply these values with the frequency. You'll get it as 138, 91, 45, 112, 68, and 54. Now sum up these values. That is sigma fi mod xi minus m is, when you add it up, you will get it as 508. Now, mean deviation about median is sigma fi mod xi minus m upon n. N is nothing but the total number of observation. So 508 upon 50. That is 10.16. This is the required mean deviation about median for the given data. Next type of measure of dispersion is standard deviation. So we have three different types of data and we use three different formulas to calculate the standard deviation. And this standard deviation is denoted by this, like this. And this standard deviation is always calculated about the mean value. If you see the first type in this, that is for ungrouped data. If the data is ungrouped, like only data points are given, then we'll use this formula, that is sigma of data point minus mean whole square upon n. Capital N is nothing but the total number of observation, and we'll take under root of this whole value. Similarly, for group data, we will take the frequency into the consideration. This frequency we have already discussed in the concept mean, right? So we'll use this. It will be easy to understand if we take a problem. If we solve examples, you'll get to know it. And the third type is a computational formula. This formula is basically used if the data is good, if the data points are good. But when you calculate the mean, you will get in fractions, or if you get in decimals, it will be very difficult to use this formula. So from this formula, we have derived a new formula so that some of the data points will give you a good number, and mean square we can do it separately. So how we derived it? Let me show you. So the first formula is this, that is sigma is equal to standard deviation is equal to sigma of xi minus x bar whole square upon n under root. Just do the a minus b whole square. This is nothing but sigma a square minus 2ab plus b square upon n under root. Now, just multiply this sigma to everything. That is sigma xi square minus sigma 2xi x bar plus sigma x bar square upon n under root. Now this will be sigma xi square only. If you observe, there are two constants. One is 2 is the constant, and x bar is also constant. Mean is also a constant number. And here also mean is also a constant number. So take it out. It will be 2x bar sigma xi. When you take x bar square constant, nothing will remain. So just simply write mean square upon n. Now, if you distribute this n to all the three terms, that is sigma xi square upon n minus 2 x bar sigma xi upon n plus x bar square. Here, there is one left out inside, that is sigma 1. 1 is constant left inside, right? So here it will be sigma 1 upon n, and that is under root. Now this will remain as it is, that is sigma xi square upon n minus 2x bar, and this sigma xi upon n is nothing but mean, right? It's a basic mean formula. And here sigma 1, that is sigma of natural numbers, that is n only. So this and this gets cancelled. So here it will be x bar, and here one more x bar. So it becomes x bar square plus x bar square. Now we can write this as sigma xi square upon n minus 2 minus 1, that is 1 x bar square. So this is how we got the third formula from the first. So this formula is used when the data points are very good, like whole numbers, but the mean is something which is fractional or in the decimal values. This formula will help you to calculate much easier. So let's see examples and solve it. And one more concept to discuss over here is variance. So before going to the examples, let's see the last concept in this part, that is variance. Variance is nothing but the square of standard deviation. Square of standard deviation. So it is denoted as like this, standard deviation ka square. Similarly, the same formulas will be for ungrouped data. Variance will be just remove the root. Everything remains as it is. And it is also calculated always around the point, that is mean. This is for ungrouped data. And for group data, it will be sigma frequency upon xi minus x bar whole square upon n. Just remove the root, that's it. And for the computational formula, sigma square will be, and the for third type, that is computational formula, variance will be sigma xi square upon n minus mean square. So variance is nothing but the square of standard deviation. So now let's solve few examples. In this question, we need to calculate the variance of first 50 even natural numbers. So what are the first 50 even natural numbers? That is 2, 4, 6 till 100. So the number of observations will be 50. To calculate the variance, first we need to calculate the mean. So the mean will be 2 plus 4 plus 6 plus so on till 100 upon 50. Take 2 common from this. The remaining will be 1 plus 2 plus 3 till 20, sorry, 50. So it's the nothing but the sum of n natural numbers, that is 50 natural numbers. So n into n plus 1 by 2. N is nothing but 50, n plus 1, 51 upon 2. Though, so you will get mean as 51. Now, what's the formula of variance? Variance is equal to sigma xi square upon n minus mean square. I'm using the third formula, that is computational formula, because it will be easier. So sigma xi square is nothing but the square of the data points, that is 2 square, 4 square, 6 square, so on till 100 square upon n. N is nothing but 50 minus mean square, that is 51 whole square. If you take 4 common, the remaining will be 1 square, 2 square, 3 square, so on till 50 square upon 50 minus 51 square. This is sum of squares of n natural numbers. So n into n plus 1 into n plus 1 by 6. N is nothing but 50. N plus 1 is 51. 2n plus 1, that is 101 upon 6. 50 into 6 minus 51 square. So 50 50 gets cancelled. 2 times, 3 times, there's 3, 17 times. So when you simplify, you will get the variance as 833. So the required answer is option D. In this question, it is given as the outcome of each of 30 items was observed. So the number of observations are 30, in which 10 items gave an outcome that is half minus D. And remaining out of 20, 10 items gave half outcome. And the remaining 10 gave half plus D outcome. So basically, there are 30 observations, and in which 10 gave outcome as half minus D, and the more 10 gave outcome as half, and the remaining 10 gave outcome as half plus D. Now, which kind of data it is? It is a grouped data. So frequency comes into the picture. And also the variance is given in the question, that is 4 by 3. So this is a grouped data. So for the group data, first we need to calculate mean. For group data, what is the mean will be? We have also seen the formula, that is sigma fi xi upon sigma fi. Sigma fi is nothing but also n over here. Okay, 30. Fi xi is frequency. How many times? 10 items into outcome. That is half minus d plus 10 into half plus 10 into half plus d upon 30. Now just take 10 as common. Inside it is half minus d plus half plus d upon 30. dd gets cancelled. This is 3 by 2 upon 3. So the mean will be half. Now the variance value is given. So using variance formula, let's find it out, the value of mod d. So what's the formula of variance? Sigma square is equal to A for the group data. Sigma fi xi minus mean whole square upon n. Now this can be written as sigma fi xi square upon n minus mean square. So here it will be 10 into half minus d whole square plus 10 into half square plus 10 into half plus d whole square upon n. N is nothing but 30 minus half square. So let's take 10 common. Inside it will be 1 by 4 plus d square minus 2d. Sorry, 2 into a into b, that is 1d, plus 1 by 4 plus 1 by 4 plus d square plus 2ab, that is plus d upon 30. 0, 0 gets cancelled, minus d plus d gets cancelled. This is 1 by 4. Now it is, and in the question, the value of variance is given as 4 by 3. So this 4 by 3 is equal to 3 by 4 plus 2d square upon 3 minus 1 by 4. Take this side plus 1 by 4, it becomes into 3. I'm taking this 3 also. 3 by 4 plus 2d square. So 16 plus 3, 19 by 12 into 3 minus 3 by 4 is equal to 2d square. This 3 times go with 4. 19 minus 3 is 16. 16 by 4 is equal to 2d square. This goes with 4 times and this is 2. So we'll get d square as 2. So d will be plus or minus 2, root 2, sorry, plus or minus root 2. But in the question, it is asked as mod d value, that is root 2. So the answer to this question is option B, that is root 2. So if you simplify this, we'll get it as x square plus y square plus 2xy is equal to 14 square is 196. And from equation 2, x square plus y square value is nothing but 100. So 2xy will be 96. And okay, like let this value be as it is. Now, let's use x minus y whole square formula because we just want the mod of x minus y. So here we can write it as x square plus y square minus 2xy. X square plus y square is nothing but 100 minus 2xy. We have just derived the value that is 96, which is nothing but 4. From this, the mod of x minus y will be under root 4, that is 2. So the required answer to this question, that is the absolute difference of the remaining two observation, is option C. In this question, the mean and the variance of 7 observations are given as 8 and 16 respectively. So there are total number of observations are 7 and mean is given as 8 and variance that is given as 16. If 5 observations are 2, 4, 10, 12, 14, then the absolute difference of remaining 2 observations is how much? So data is given as 2, 4, 10, 12, 14. There are 7 observations, but 5 observation points are given. So let us assume the remaining 2 observations as x and y. We need to calculate the absolute difference of these two observations. Okay, now let's go with the mean. So mean of the given data will be sum of all observations upon total number of observations. That is sigma xi upon n. It is given as mean is how much? 8. It's already given in the question. Sum of observations 2 plus 4 plus 10, 12, 14, x plus y upon n. N is 7. You will get 56 is equal to 42 plus x plus y. So you will get the value of x plus y as 14. So assume this as the equation 1. They didn't ask the sum, they have asked the difference in the question. Now let's use the variance. So variance will be sigma xi square upon n minus mean square. So in the question, variance is given as 16. Sigma xi square is nothing but 2 square, 4 square, 10 square, 12 square, 14 square plus x square plus y square upon total number of observations, those are 7, minus mean, that is 8, it's already given in the question, that is 8 square. So 64 plus 16 is 80. 80 into 7 is equal to 4, 16, 100, 144, 169 plus x square plus y square. Now, when you simplify this, you will get it as 560 is equal to 460 plus x square plus y square. So you will get it as x square plus y square is equal to 100. So assume this equation as equation number 2. Now we need to find absolute difference of these two observations, that is x and y, using these two equations. From the equation 1, if we square it on both sides, that is x plus y whole square is equal to 14 square.